This is problem number 9 from section 9.2. In this problem it says it takes 13 units of carbohydrates and 7 units of protein to satisfy David's minimum weekly requirements. The meat contains 2 units of carbohydrates and 2 units of protein per pound. The cheese contains 3 units of carbohydrates and 1 unit of protein per pound. The meat costs $3.40 a pound and the cheese costs $4.70 a pound. Find how many pounds of each are needed to fulfill the minimum requirements at minimum cost. So we need to figure out, it says find how many pounds of each are needed to fulfill. So we're looking for pounds of meat and cheese. So we're going to say that X equals the pounds of meat, and we're going to say Y equals the pounds of cheese. Now, we're going to write a few equations here. We're going to start by, let's see, they say 13 units of carbohydrates and 7 units of protein to satisfy David's minimum weekly requirements. So he needs to get a certain number of carbs from meat and cheese and a certain number of protein from meat and cheese. So I think we need to write an equation for the carbs. And we'll call it carbs equation. And we need to write an equation for the protein equation. And then finally we need to write an equation for the cost. Okay, for the carbs equation, it says that meat gives 2 units of carbs. And that's 2 units, obviously, per pound. X is the number of pounds of meat. So that's 2X will give you the number of carbohydrates for the meat that you've eaten throughout the week. And then the number of carbohydrates for the cheese, 3 units of carbohydrates. So 3 units for the cheese, so that's plus 3Y. And that's got to be at least, right? It takes 13 units of carbohydrates. So it's got to be at least, it's got to be greater than or equal to 13. For the protein equation, you get 7 units, you get 2 units of protein for the meat. So that's 2X for the meat. For the cheese, you get 1 unit of protein per pound. Cheese is 1 unit of protein, so it's plus 1Y. And that has to be greater than or equal to 7 units of protein. So greater than or equal to 7. The cost equation, well, you know that the total cost, we'll call it C, is going to equal, so we'll write that up here, C equals total cost. So C is going to equal the price for the meat, so that's $3.40 per pound, so that's per pound X, plus $4.70 per pound, which is Y. Okay, now we can go ahead and graph these. If we go ahead and graph these, now these might not be the easiest equations to graph. So because of, you can see right here, 2X plus 3Y greater than or equal to 13, you can see that as you go to graph this, you're going to end up with a fraction for your y-intercept, but we can try and come as close as we can, basically as close as possible. And you might even solve these just for the minimum requirement, or so you could solve these two together to find the minimum possible requirements and then just plug that into the cost equation. That actually might be the best way to do this problem. But let's graph them first because that's what we've been doing. So we're going to subtract the 2X here. Remember putting them in slope-intercept form. So you get 3Y greater than or equal to negative 2X plus 13. Now we're going to divide by 3. So you get Y greater than or equal to negative 2/3 X plus 13 over 3. On this problem, we're going to subtract the 2X. And we get Y greater than or equal to negative 2X plus 7. Now, because I have a y-intercept of 13 over 3, there's really no way I'm going to try and graph this by hand to get an exact answer. I think that's not going to work out how we want it to. So what we're going to do is we're going to use our graphing calculator, and we're going to plug this in. Now when you use the graphing calculator, we're going to have to plug in with an equal sign. So then we're just going to have to interpret the inequality signs. Let's start with the top equation. So I'm going to say, make a fraction here, -2 thirds x plus, let's make a fraction here, 13/3. So that's going to be graphed in blue. All right, let's make sure we mark this. If this is the blue equation, and this one is going to be, the next one's going to be the red equation. So we got a blue equation, we got a red equation. Now for the red equation, we're just going to say -2x plus 7, so that's pretty simple, -2x plus 7. Let's go to the window, make sure I assume this is going to just graph the window from 0 to 10. Let's go 0 to 10 because, I mean, obviously we're going to be buying meat. We're not going to get any negatives, so we're probably good there. Let's graph this, see what it looks like. So there's our blue line. This is this one. Now remember, it says greater than or equal to, so we're going to be shading above here. And this one is greater than or equal to, so we're going to be shading above here. So our solutions are going to lie in this region on the screen. So really I want to know, what are the different vertices, right? First of all, what are the intercepts, right? Because this one up here is like an intercept, this one up here is an intercept, and then they intersect here. Those are really the 3 points that we need to check. So let's find where they intersect by saying second calc, and let's go to intersection. And we can click the first curve. Then we got to pull the second curve back. Now notice the x value says 5 and the y value is -3, so it's actually down there. So I just need to get back to where my x value is in the 3 range. Oh, there's that cursor. So you just always got to look, where's the x value at? Just get on the other side of that intersection point. Have a guess. It says our intersection point is 2, 3. So one coordinate we need to check. We need to check 2, 3. So we'll call this, I want to call vertices, we'll say, how about possible points? And we're going to call this 2, 3 is one of them. Now we need to go over and check out what this one is, where it intersects. And it looks like it intersects right at 7. So 0, 7 is another one. Now what we could do to make this better, because obviously the least amount of meat that you can buy is 0, and the least amount of cheese that you can buy is 0. So we actually kind of missed some constraints here. We could have said a couple of equations. We could have said that x has to be greater than or equal to 0, and y has to be greater than or equal to 0 as well. So actually, let's go back to the graph here. Well, we can just look at it. We know y is greater than or equal to 0 is right here, facing upward, and x is this direction. So if we just get to that point where the x-axis is, or sorry, the y-intercept is, which we did 0, 7, we have the coordinate. So then we just need to go down to find the intercept here. And we could, because this is the blue line, we're really looking for the x-intercept here. What we can do is take the blue line's equation, which this is the blue line, and we can find the x-intercept algebraically. I think that's probably the easiest way because we're not getting a straight answer there. So let's go ahead and find the x-intercept algebraically. So we're going to say y equals -2/3 x plus 13 over 3. If we want to find the x-intercept, we're going to set y equal to 0 equals negative 2/3 x plus 13 over 3. Subtract that over negative 13 over 3 equals negative 2/3 x, and then we're going to multiply by 3. So if we multiply by 3 on each side, that cancels the 3's, leaving with negative 13 equals negative 2x. Divide by negative 2, and you end up with 6.5 equals x. So this x-intercept is 0, that's our other coordinate, or sorry, 6.5 comma 0. And I didn't know how to snap to it right there, so that's why I did it algebraically right here. So we need to check these 3 points to see, we know these are going to meet the needs of David's minimum weekly requirements, basically. Now we just need to check to see which one costs the least amount. So let's go ahead and do that. So we're going to say lowest cost. I'll use a different marker. Lowest cost. So 340 times 2 plus 470 times 3 equals, we're also going to do 340 times 0 plus 470 times 7. And then 6.5, not 6.5, 3.4, we'll just do it backwards here. Should have been 3.4 times 6.5 plus 470 times 0. Okay, let's throw those in. So 340 times 2 plus 470 times 3 gives you $20.90. For this one to be 0, so it's just 4.7 times 7 gives you $32.90. And then finally 6.5 times 3.4 plus 470 times 0, we don't even need to add. This is $22.10. So which one of these scenarios has the lowest cost? This one does. And if you remember, it says minimum requirements met and minimum cost. That's the minimum requirements met, that's the minimum met, that's the minimum cost. So we can say David needs to eat 2 pounds of meat and 3 pounds of cheese to minimize requirements and cost. Hopefully that makes sense.